Welcome to this explainer. Look, today we're going to take advanced trigonometry and completely transform it from, some abstract textbook chore into your absolute ultimate tool for visualizing reality. If you've ever felt like the basic math you learned back in the day was just keeping you trapped in a rigid little box, well, you're exactly in the right place. Because today, we are finally breaking out.
Think about it for a second. Imagine a game developer trying to set up a dynamic, rotating 3D camera angle for the next big blockbuster video game. They need that camera to pan perfectly smoothly around a character in a full 360-degree circle. Basic right-angle math? Yeah, it simply can't solve that problem. The physical world around us and the digital worlds we build, they just don't exist solely within neat, acute angles. So, what actually happens when we need to calculate the mechanics of a world that is constantly in motion?
Well, here is our roadmap for today. We're going beyond right triangles, exploring the Cartesian plane shift, cracking the cast diagram, solving real-world 2D problems, and finally, diving into the math of reality.
All right, let's jump right into Section 1, Beyond Right Triangles, Escaping the 90-Degree Box.
For years, basic trigonometry has basically trapped us inside this strict 90-degree limitation. I mean, it's a fantastic foundation, right? But the real world definitely doesn't stop at 90 degrees. That's where advanced trigonometry comes in and totally liberates us. It lets us explore angles of absolutely any size in dynamic motion. It takes us from those static, boring triangles drawn on a piece of paper all the way to calculating actual rotational movement in the real world. So, let's see what happens when we map those out in Section 2. The Cartesian plane's shift, a new dimension for angles. This right here is a massive paradigm shift. We're literally trading those old, rigid triangle walls for a full 360-degree Cartesian plane. Instead of just talking about opposite sides and hypotenuses, we're actually redefining sine, cosine, and tangent using an xy coordinate system and a radius, which we just call r. Imagine a point defined by x and y dynamically moving around a circle on this plane. As it moves, the values of our trigonometric functions are changing in real time. We're literally mapping angles in motion. But to navigate this new 360-degree world, we definitely need a reliable map, which brings us perfectly to Section 3, Cracking the Cast Diagram, the ultimate mathematical cheat code.
Think of the cast diagram as your personal decoder ring. As your coordinates flip across the 4 quadrants on the Cartesian plane, this incredibly simple tool instantly reveals which trigonometric ratios stay positive. Whether it's sine in the 2nd quadrant or cosine in the 4th, you honestly no longer have to get lost in the weeds of complex coordinates. The map just does all the heavy lifting for you.
Okay, let's put these new rules to the test in Section 4, Solving Real-World 2D Problems, Bringing the Math to Life.
Now that we have this expanded toolkit, we can really tackle the physical world. Whether you're trying to figure out an angle of elevation to look way up at a skyscraper, getting your exact navigational bearing out at sea, or, analyzing complex geometric constraints that basic math simply couldn't touch, these advanced rules make the impossible absolutely possible.
Picture this. You need to find the height of that massive skyscraper. First, you just identify your real-world distance and your angle of elevation. Then, you map that entire scenario directly onto the Cartesian plane using your x, y, and r coordinates. Finally, you just apply the correct ratio from your cast diagram. Boom! What looked like a totally impossible measurement instantly becomes a straightforward, simple calculation.
And hey, you definitely don't have to do all this dusty math on a chalkboard anymore. By jumping into interactive problem-solving environments, using dynamic geometry tools like Polypad, you can visually build and interact with these solutions right there on your screen. It completely bridges that gap between abstract numbers and actual visual reality.
All right, our final stop today is Section 5, The Math of Reality, Wielding the Power of Angles.
It is honestly mind-blowing when you stop and realize who actually relies on this stuff to build our modern world. It's definitely not just academics. We're talking about surveyors mapping out tricky land boundaries, air traffic controllers dynamically tracking fast-moving planes in 3D airspace, even civil engineers making absolutely sure our bridges are stable. Oh, and game developers calculating those super immersive precise camera pans. Literally, from safely landing a massive 747 to rendering your favorite digital worlds, these professionals lean entirely on advanced trigonometry.
So, here is the absolute core takeaway for you today. Advanced trigonometry literally allows us to see and calculate dimensions that are incredibly impractical, or frankly, totally impossible to measure directly. Think of it like a human superpower.
It lets us calculate these vast distances and highly complex spatial relationships without ever needing to pull out a physical measuring tape. It simply unlocks the hidden geometry of the whole world around us.
Well, thank you so much for joining me for this explainer. We've journeyed all the way from the rigid confines of the right angle, expanded out into the dynamic Cartesian plane, cracked that cast diagram, and seen exactly how this math builds the real world. So I'm going to leave you with this final challenge. Now that you finally have the cheat code, how are you going to use advanced trigonometry to visualize and measure the hidden dimensions of your own world? Keep exploring, keep visualizing, and I'll catch you in the next explainer.